Code please.
Welcome to Code Please. In this channel I try to teach you a little bit about computer programming using the Elixir language. If you find this content useful, please consider subscribing and sharing with your friends. Now let's get into today's video. Welcome back to my channel. In the last video, we finished our series on supervision trees, gen servers, and other process-related ideas of the Erlang virtual machine and Elixir. This time, we are going to explore how to write a simple web server that we could potentially have running on the internet, accepting requests from web browsers from all over the world. For that, we will turn to a project called Cowboy, a small, fast and modern HTTP server for the Erlang virtual machine. Paraphrasing from their website, Cowboy is a high-quality project. It has a small code base, it's very efficient both in latency and memory use, and can easily be embedded in another application. Cowboy aims to provide a complete modern web stack. This includes HTTP 1.1, HTTP 2, WebSocket, server-sent events, and web machine-based REST. If you don't know about these topics, don't worry. This link provides some background information about the internet of today, namely its current standards. Since Cowboy is plain Erlang, and we want to write our programs in Elixir, we can use a fantastic library called Plug to simplify its usage. Plug is both an Elixir specification for composable modules between web applications and also some connection adapters for different web servers in the Erlang VM, Cowboy being the most used one. Plug allows us to create a chain of modules that get called sequentially when a web request comes in, and lets us clearly separate concerns like security, authentication, header management, session information, amongst many other things. Okay, so let's take a step back and try to think about exactly what it is that we're trying to build. A web server is nothing more than a computer that lives on the internet, but it's a computer like any other computer, like my computer or your computer. The only difference is that it's 24/7 accessible to the internet, and you can basically connect to it at any time. And this computer has an address on the internet. This is what is commonly called an IP address or Internet Protocol address, and it's a number in this format, a bunch of digits separated by dots, and each computer that lives on the internet has a specific IP address, and there's more intricacies to this. There are subnets inside the internet, like your home network is a network that has its own set of IP addresses, but you get the gist of it. So a web server on the internet has an address, and then this computer can listen to your requests on any given port. And a port is, you can think of a port as a simplified version of a sub address inside of the computer. Like imagine the web server has a bunch of doors and each door has a number. This is basically the port on the computer. So in order for us to connect to a web server, we just need to know the IP address and the port that we want to connect to. And when you open your web browser, like Edge or Chrome or Firefox or any of those, and you ask it to connect to a website, you are basically telling the browser to connect to a particular IP address and a particular port. And the port is usually omitted from the URL, but it's typically either 80, which is the standard HTTP port, or 443, which means it's HTTPS or HTTP secure port. Depending on whether the URL you're trying to access to starts with HTTP or HTTPS, you're going to one port or the other on the target computer or the target web server. And there's one extra step to this, which is people are generally not very good at remembering numbers. So the internet would be very much unusable if you had to know the IP address of all the web servers that you want to access. And this is why name servers exist. So every time you go to your URL and you input something like Nike.com or something like that, your browser first makes a request to a DNS or domain name server, and these are basically this is basically a cluster of computers on the internet that knows how to resolve names into IP addresses. So your browser will go behind the scenes and ask one of these DNS servers, what is the IP address for Nike.com? And then it gets the IP address, and then depending on whether you're asking for HTTP or HTTPS, it knows to connect to the IP address and the correct port, either 80 or 443. Could be another, but for our simple example, that will suffice. So a typical web connection from your browser to a web server would be the browser goes to the DNS, gets the IP address, and performs a request to a given IP address, like in this case 125.49.731, and in the port 80 or port 443. And then the server process, which is nothing more than a program running somewhere listening for connections, will interpret this and will also interpret the URL part after the slash. So if you go to mysite.com/page1, the first part of the domain would give you the IP address and the port to connect to, and the second part would tell the web server that you're connecting to which resource you are interested in. And in this case, we're asking for page 1, so the server process will identify this, run the code associated with that page, and format a response that can be a web page, some HTML that you see on your browser, or some JSON, XML, or any other formats that the server supports. So this is in a gist how web servers work and how your connection from your own web browser to a web server works. So let's go and try to implement our first web server in Elixir. So the first thing that we're going to do is to create a new Mix application. And the reason for starting a new application here is because I already know that I want to run this web server under a supervision tree later on. So we might as well create this as an application. And it also simplifies because we get a new folder with a bunch of stuff, and we can open that on Visual Studio Code and more easily edit our files. So let's create a new application with Mix New, and let's call our app My First Web Server. Okay, and if we press enter, Mix generates the project for us. And if we go inside, if we go inside, we can do mix deps.get, which should tell us that the dependencies are up to date. And as we know, this does nothing for now, so let's open up Visual Studio and open a folder, and we can open our particular project folder here, and we get our files. So right now our Mix file has nothing. The first thing we want to do though is to basically add the Plug Cowboy as a dependency, and that's it really. Well, now we can just go to the to the console and run mix deps.get again. It should retrieve Plug and Plug Cowboy and a bunch of other dependencies from the Plug Cowboy project, and then we can start to implement our simple web server. Well, let's create a new folder called My First Web Server. This is always a good practice to keep our code kind of organized with different modules, since we have this module here in the base, and we can get rid of this hello world that is generated by default. We should have an equivalent folder where we're going to put our code basically, and we're going to call this web server. We can do def m if you have some extensions in VS Code to run some snippets based on Elixir. You already get like these snippets that pre-generate a bunch of code, but you can just type it yourself. And then we can just define our module as my first web server dot web server. And now what we need here is basically to import plug.con. So we get all the code for a plug connection inside of this. And then we need to implement two functions. The first one being the init function, where we accept some options for the creation or for the initialization of this plug. And we don't really need to do anything here other than return options. We could do some modification to the options if we wanted to, but we can just add some inspect here so we know that the plug is actually being called. So we can do plug init, and then the other function that we need to implement is the call function, and this is actually executed when the plug sequence is executing. It gets, and this plug in particular gets executed. It's the call function that gets called. We accept the options as second argument and the connection as the first argument. And we are going to inspect this con in a second so we can see what kind of information plugs and specifically plug cowboy puts in there. But for now, let's just do con equals put resp content type, and this basically defines what kind of what is the format of the information that we are sending back to the client, to the browser, or to the command line client. In this case, it's going to be text plain. We're just going to send back a plain string, and then we can do send response or send resp with the con. We're going to send it back a 200 HTTP code, which means okay. And we are going to send back the string hello world. If we save this and we go back to our console, we can pretty much do IEX-S mix. So we start the application in mix mode. It's going to compile a bunch of stuff. And after this is done, we can basically initialize our web server. I'm just going to copy paste, but you can type it. The way to initialize it is with plug.cowboy.http, and we pass the plug that we want to run as our server, basically. So if I execute this, I should get back an OK and a PID of the started process, and we can see that it ran the plug init immediately, and now our web server is basically running. So if we go to localhost 4000, we get hello world. And we don't get any information in the console. It's running behind the scenes because we don't really have any debug information there, but we are going to add it soon. So let's just kill this server for now. And if we go back to our code, we can see that we have this code here. And if we take a look at these two functions that we are calling, put resp content type and send resp, we can see that they both take con as the first argument. And I don't remember if I already mentioned the functionality of Elixir called piping, like piping functions, but this is a really cool thing. So whenever you have like a sequence of functions that depend on one another, and where the first argument is always what the other function returns, you can pipe these functions in a really clever way, and this makes the code super readable. So one alternative to these two lines of code here could be con, and then piping this con into the put resp content type here, and the piping operator will make sure that con gets passed as the first argument. So we don't need to actually specify the first argument. It's just going to implicitly be injected into there. And then we can also pipe the return of this into the send resp and remove the con here. And since both these functions return a con, we start with the con, we pass that con into put resp content type with more arguments, and then we pass the resulting con from this function into the send resp with more arguments, and it returns a con. So all this code becomes very, very elegant when you try to read it. And this is another reason why I love this language, is partially because of being able to pipe function calls. So yeah, one thing I didn't mention is if we start our server, and I lost it, but I can just copy it here. If we start our server, the way you stop a Cowboy server running HTTP is you can do plug.cowboy.shutdown, and then if you pass it the name of the module .http, because in this case we started an HTTP server. If we started an HTTPS server, it's a different protocol. We probably would need HTTPS. Don't quote me on that, I'm not sure, but if you do this, you just kill the server basically. You stop the server. So next thing we want to do is probably make sure that our web server is resilient, right? We want to make sure that it cannot crash. If we remember from our experiences with the supervision trees, if we start, like, let's say we start our server and then we go into observer.start, and if we go, and I apologize for the size of the interface here, but I can't really zoom in. But if we take a look at the applications, if we kill branch particularly, which is the underlying web server that Cowboy starts, if we go to our web server now, we can see that it died. And so we don't want this to happen. We want whenever our web server dies, it just, you know, restarts itself. So we want to put this in some kind of supervision tree. And the way we're going to do that is by going back to VS Code, and we can just create a new application that we're going to start from the mix file. And I'm just going to copy paste this. This is not very interesting code, but we can just define an application like this. You already saw this before, where we put a web server here, and we can actually use this part to specify the port and the protocol that we're going to use. We're going to use the scheme HTTP or protocols HTTP, and we want to use the port 4000 for this. And basically we want to start our server like so, with supervisor start link. This is not news for you anymore. It's just a normal supervisor overseeing the web server. And then we can go to mix as well, and we need to tell mix to start our application. So, and the way we do that is by using the mod option on the application, and we just tell it to start this web server. And now if we go back to our console, we can do IES -x mix, and we see that immediately it starts the plug and the web server is running. So if we go here and we refresh the page, we should have the same thing running. And now if we take a look at the observer, we can see our application here, my first web server, and we can actually see all the processes that it spanned. And this is somewhere here is ranch running, and it spans, or it spawns a bunch of different processes that are listening on that address. And the reason it does this is because we want to be able to handle multiple connections at the same time, and it's very expensive to be spawning processes all the time. Well, not very expensive, but it's more expensive to spawn a process than to have a process already listening and being able to handle some work. So that's the way that's the reason why it's so many processes are launched at once here. But again, if we come back to this and we kill this process, we can see that it revived itself again, because now it's under a supervision tree on our application, and that's pretty cool. So if we go back to the to here, we can see that it's actually running. And actually, if we go now to our code, we can inspect this con, so you can see what's under there as well. I'm not sure we need to recompile, we probably do. And if we go to our browser and refresh, we can see that our con, or our plug.con structure, has a bunch of information here related to the web request that we just did. So our browser connected to the server and told it to get some information, and you get like the host, you get the method that the browser used. It can be get or post or whatever. You can see the parameters that are being passed. In this case, it's just empty. You can see the port the server is listening in. So there's a bunch of, you can see request headers. There's a bunch of information here that is really specific to web servers, and it's very useful information. But the point is that the plug.con object is just, you know, a normal Elixir structure that keeps some information and gets passed down all the plugs until it reaches, and then until it's returned back to the browser as some kind of response data, basically. Okay, but now you can say, okay, but we if we go to the browser, and typically if you go to a website, there's usually some organization on the web servers in terms of the path of the URLs that you can access. So it would be nice if we could access like /hello and get a different response, and I don't know, /hello2 get a different response. That would be pretty neat, right? We could like pattern match on a kind of resource that the user is asking for specifically on our web server, and we can provide it with different information depending on that URL. So the way we can do that is, or the way that Plug allows us to do that, is by using a special plug called the router, which is a plug itself. And the router allows us to specify multiple entry points for the server. So let's take a look on how we can do that. I'm just going to remove this con here, and we're going to implement a new web server here, or a new plug. Let's call it Webserver 2. It's a pretty weak name, but you know, serves our purposes. And what this module is going to have, let's just first name it correctly. My first web server dot Webserver 2. And what this is going to do is use plug.router. And using plug.router allows us to use some cool macros. And let's not discuss macros now, but it's kind of, imagine a macro is like, it's a way for us to inject some code for the compiler automatically. So imagine that it's kind of, if I type like, for instance, plug match, this macro would replace, when the compiler is compiling, it would replace this plug match with some code. So it's kind of a cheating way of injecting code instead of writing it. And for defining a router, we need to define two plugs. We need to define the match and the dispatch. I can type plugs, and then we can do and then we can specify our entry points or our URLs that we want for our server. So the first one we're going to specify is like get /hello. So if the user types in the browser /hello, he should get this, and we're just going to send back a normal con 200 and world. Okay, and you might notice that I'm not specifying the content type here. You're not forced to, but it's good practice, but we're not forced to. So we can just do this. And now I need to start this web server, and I can just start another web server like at the same time. So I can just, you know, duplicate this line here with the children of our supervisor, and I can instantiate this one on a different port. Now, this is important because a program in a computer can only attach itself to one port at a time. So if I try to do the same on 4000, you would have a confusion here, because it would try to start on a port that is already opened on the operating system level, and it would not work. So we're going to start our second web server, or the router web server, on port 4001. And if we go here, we terminate and we open this again, we can see plug.init, our main web server, or first web server, is still running. So if I refresh this, I should still get the same result. But now, if I open a new connection to port 4001, I get an error because I only specified the /hello URL, right? But if I specify / or the root, it's called the root URL, it's not going to work. But there's a way to fix this, and it's very easy. We can just go here and do like a match. By the way, this is all using pattern matching behind the scenes, which is pretty cool. So we can do this, and this is going to match on any URL that doesn't get matched before. So the order is important here. You should get the more specific URLs first. But if we do this, and if we recompile, and we go back to our, we should get oops. And if I go to /hello, I should still get my hello world. And now I could basically just, you know, create any amount of entry points for my web server that I would like. I could just do, I can specify a hello world 2, and if I recompile go back to the browser and ask for hello 2, I get world 2, and I can still get hello world. And this is just a plug, which means that I can even go as far as I could forward, like I could do something like this. There's another macro from plug called forward. I could forward, for instance, /admin to an hypothetical admin router. And I would just need to implement a module called admin router that also uses router and does exactly the same thing, but with different entry points and with different behavior. So it's pretty powerful stuff, the plug system and the routing system. Another thing I can do here, I'm just going to delete here, is if I want to see some debug information about the requests that are being called here, I can just put another plug, and it's just going to route this connection through this plug and this plug and this plug, and then try to match against all of these. So I can just add more plugs here as I see fit, and the connection is going to go through all of them. If I use this logger, what's going to happen is if I refresh, I now can see information about what's being called on the server for free. You can see that someone made a GET request to /hello, and the 200 was sent back. And I don't know why it's printing this gibberish. I think this is the time it took. I think this is microseconds, probably. Yeah, this is the micro symbol. So it replied the 200 HTTP status code in 0 microseconds and in 102 microseconds. And if I go hello 2, I can see this. And if I go like this, I can see, you know, you get the idea. And finally, so you get an idea of the base plugs that exist, we can go to the plug GitHub page, and we can see down here some plugs that are already there out of the box that you can use, like for instance for HTTP, basic HTTP authentication, for form submission protection, things for logging, the one that we just used. I don't know, there's a bunch of session information. This one allows you to enforce the requests being using secure HTTP, and this one allows you to serve static files like images, CSS, JavaScript, etc. So there's a bunch of plugs already written, and you can basically just write your own plug. It's as simple as implementing the init and the call functions, and then injecting them into some kind of pipeline, or a router in this case, for instance. So that's it. That's one of the simplest ways to implement a web server in Elixir. It's by using Plug Cowboy. And we're going to see in future videos that, for instance, the Phoenix framework does all this behind the scenes, but gives us a more higher level way of defining our web server, along with many other things like support for WebSockets, serving the static assets that I was talking about, allowing us to include some CSS and JavaScript, and writing web pages in a very simple way, not having to, you know, directly having to handle content types and the things that we were discussing in this video. And you're going to see it simplifies a lot, but I really wanted to make this video because I think it's a good foundation to know how web servers can work in Elixir, and Plug Cowboy allows us to do that really easily. So I hope you enjoyed, and I'll see you in the next video. Cheers! If you like this video, please consider subscribing and liking and sharing with your friends. It really helps the channel to grow. Thank you.